Good morning, everyone. Myself, Monica Nancy Priya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W3017 Embedded C Programming in the Regulation 2021. In today's video, we are going to learn about one of the most important core topics of 8051 microcontroller, that is memory organization. This topic is very important and for the real-time embedded system design. Um, just try to visualize how memory works inside the 8051. Let us understand the basic idea of the 8051. This 8051 is divided into two main types. This is first important type. First, what are they? Program memory and data memory. The program memory is used to store the program. Okay, first program memory was it is used to store the program, and the data memory is used to store temporary data. Okay, so program memory is used to store the program, meaning the instruction that the CPU executes. What are the instruction which is given by the CPU that it executes? The data memory is used to store temporary data such as variables, intermediate results, counters, and flags. So program memory is what to do, and the data memory is what data to work on. This is the major thing. The next one is program memory. What is program memory? In the original Intel 8051, we have 4 KB of internal ROM. This ROM stores the program permanently even when the power is switched off. The address range for the internal ROM is 0000H to 0FFH. If the program size fits inside this range, everything works internally. But what if the program becomes large? So that is the need for the external program memory comes in. This is both internal and external memory with 8051. This is only external memory. Here we see we are having the this is the internal memory, and if we want the external memory, we have connect this external memory program. Then in 8051 microcontroller, it is having only the external memory. It doesn't have the internal memory. So it is this is the ROM-less in microcontroller. This is the ROM-less internal access. So what is the program selection pin? Some versions of 8051 family, we are having the 8031, 8032 do not have the internal ROM at all. So we have the program stored in the external ROM. So that is why we are using the microcontrollers cannot work alone. They must be connected to the external memory chip, and it is also have the external access pin also. In EA stands for external access. This pins explains the CPU. EA is high, the program is inside the internal ROM. The EA is low, the program is connected to the external ROM. Already we have seen the 89 C51 in that 8051 and 52 which is connected to the supply, and 8031 and 32 which is connected to the ground. So that is the internal RAM. That is the original of in data memory also. In the first 128 byte of RAM, the first 32 byte is the memory from the addresses of 00H to 1FH. Consists of 32 working registers that are organized for 4 bands in the 8 registers in the each bank. So these are the registers. Here the port P0, P1, P2, P3 is here. And for the register B for the arithmetic, DPH is the addressing external memory and the addressing internal memory. These are all used. And for this SP is the stack pointer. And for the T mode is the timer counter mode control. Here the 32 bits are used in the data memory. The original 8051 has 128 bytes of the internal RAM. So this RAM is used to store variables, the temporary data, stack, flags. So this memory is volatile, meaning data is lost when the power is off. Next one is the interfacing. Interfacing external memory with the 8051 microcontroller. So the first 32 bits of bytes of RAM from 00H to one FH are reserved for working register. These 32 bytes are divided into four register banks. That is bank 1, bank 2, bank 3, bank 4. Then it is the registers from R0 to R7. So only one bank is active at a time. And the selection is done using bits in PSW register. So this is the need why the register banks are low. It's a fast context switching and the efficient of interrupt handling. In simple terms, register banks helps the CPU work faster and smarter. Then why external memory is needed? That is memory capacity. Why we are using this for the all the methods. So the memory capacity means how much data memory chip can store. It depends on the number of address pins, number of data pins. If a chip has a X address pins, it is considered as a 2 par X location. Now, wide, if it have a Y data pins, then it is said to be the Y bits per location. So total memory is 2 par X into Y because the X is denoted as a address pin. So it always denoted in the power of 2. And Y is always a data pin. So it should be multiplied with the 2 power of address pins. Next one is the memory organization. When the CPU sends an address to a memory, the data does not appear instantly. There is a small delay that is called the access time should be there. And the shorter access time means it's a faster memory and it's a higher cost. This is why the fast memory chips are more expensive so that we are always go for the type of access time chip that is the memory chip. Then the memory address decoding is the CPU only gives an address. Is it right? But how does the system which memory chip to activate? This is done only by the address decoding. So if we are decoding the address, then only the system know which memory to activate, which memory to which the program will be in the memory location. Each memory chip has the CS pin. What is meant by CS pin? It's a chip select pin. Only when CS pin is activated, the memory responds. If it doesn't, then the memory doesn't respond. You have to wait for to respond the memory. So when the CS pin is activated, when the CS pin gets on, then the memory respond for the certain read or write, whatever it is, then only it responds. Then the address decoding using normally the memories are divided into blocks and the output of the decoder select a given memory block. What are they using the simple logic gates and using 74LS138 and using a programmable logics. In this logic gate, the simplest decoding method using logic gate using especially a NAND gates. Why NAND? NAND output is actively low, so that we are using the NAND gate and the CS pin is actively low so that they match perfectly to give the data in the address decoding. And the address decoding using the 74LS138 is it has three select pins and eight active low outputs. Each output can select one memory block. Each output can select one memory block. So with one IC, we can control the eight memory chips so that we are telling that is address decoding. And the last one is enable. Enable pins of this is the enable pins of 74LS138 is G1 is actively high, that is here. G1 is actively high and G2A and G2B is active low. These pins must be properly connected, otherwise the decoding will not work. This is the enable pin for the address decoding. The next one is the programmable logic, that is PAL and GAL. What is meant by PAL? It's a programmable logic device. Instead of fixed decoders, we can use the PAL. The advantages are very high, very flexible, and can decode any address range. And the disadvantages, it must need software and need programmer hardware. So in lab, 74LS138 is preferred. So, what are the topics we have seen for the today video? We studied program memory and data memory, internal and external memory, EA, ALE, and address decoding. Next, 74LS138 and programmable logics are used. These topics are very important for the embedded system design. And please go through this memory allocation, memory organization, and we see the next topic in the next class. Thank you.